Hi, my name is Allison Snyder. I'm going to talk about the chemistry of hair perms and relaxers. First, before we get into anything else, let's take a look at the structure of our hair. Hair is a keratinous filament that grows from the epidermis layer of the skin. It is made primarily of dead keratinized cells. Our hair structure can be dissected into three main parts. The medulla, which is the innermost layer of the hair and is made up of a soft, oily substance. This layer is often absent in most hair strands but can be seen in large, thick hairs. Next, there is the cortex. This is the main component of the hair strand, containing long keratin protein chains. Melanin, which is the color portion of the hair, the texture of the hair, and also provides strength and structure. Finally, we have the cuticle. The cuticle is the outermost layer, which has scale-like cells that lay in an overlapping pattern. This is a protective layer for the inner structures of the hair. Moving on, our hair is made up of 95% keratin. What is keratin? Keratin is the foundation of our hair. It is a tough fibrous protein that forms part of our hair, skin, and nails. Keratin is made up of about 18 different amino acids, which are all connected by peptide bonds. This protein is particularly rich in the amino acid cysteine. The keratin protein structures are made up of two polypeptide chains, which are connected by three side bonds, the first of which are the disulfide bonds. These bonds will always connect two cysteine amino acids. Cysteine is rich in sulfur, hence disulfide, meaning two sulfurs. Next, we have the hydrogen and salt bonds, which connect any other amino acids as long as there is a positive and a negative charge coming together. Once we get talking about the perming and the relaxer treatments, we are going to be breaking bonds. So first, let's look at the four bonds in the keratin structure and how we can break them. First, we have our salt bonds. We can break these by changing the pH. The pH of our hair is 4.5 to 5.5. Adding water can change our pH and break the salt bonds. Next, we have our hydrogen bonds. We can break these by adding heat or water. They're non-permanent because they are easily broken as well as put back together. Next, we have our disulfide bonds, which can be broken with the use of chemicals. These bonds, when they're broken, can permanently change the shape of the hair. Lastly, we have our peptide bonds. We do not want to break our peptide bonds. The hair will fall/melt off if the bonds are broken. Now, let's look at our perm treatments. To perm our hair, we will be breaking the disulfide bonds within the keratin protein using oxidation and reduction processes, then reforming them in a new pattern to form curls. Now, how does this work? First, we are going to break the salt and hydrogen bonds by wetting the hair. Next, we will add hydrogen into the hair. This is done with the perm solution, ammonium thioglycolate. The ammonia lifts open the hair cuticle and the thioglycolate introduces the hydrogen. Now, the hydrogen pulls away the sulfur from the disulfide bonds. The disulfide bonds break because now there is nothing there holding them together. Now, all three bonds are broken and the hair is able to be reshaped into a new process. Next, we're going to add oxygen into the hair. This is done with a neutralizer, which contains hydrogen peroxide. This pulls the extra hydrogen back out of the hair and attaches it to the oxygen atoms, forming H2O. The water leaves the hair, and finally, the disulfide rejoins with the sulfur to reform the bond into a new curl pattern. So now we're going to look at the relaxer treatment. In a relaxer treatment, we are still breaking the disulfide bonds, but now we are using a process called lanthionization instead of oxidation and reduction. Lanthionization occurs because of a change in the pH. The pH of a relaxer is normally around 13 to 14. We are making the hair go from a wavy or curled pattern into a straight or almost straight pattern. Now, how does this work? First, the pH change in the hair goes from our 4.5 to 5.5 to a 13 or 14. This is a very big jump, causing the sulfur atoms to be shaken off the disulfide bonds of the keratin protein, almost like an earthquake. Next, a lanthionine bond is now formed and we no longer have a disulfide bond. We have lost one of the two sulfur atoms. After the loss of the sulfur atom and the breaking of the disulfide bond, we do not reform the bond. The bond in the protein remains broken. Now, finally, to bring the hair pH back to neutral, we use a normalizing and neutralizing shampoo. This is the final step of the process. So, I'd like to thank you, and I hope you enjoyed this quick review of how perms and relaxers work in our hair. And here's my works cited page.